Hello everyone. In this lecture, let us understand image gradients using the Laplacian filter. For this filter, our first step would be to import CV2. The next step would be to import NumPy as NP. And from the matplotlib library, we will be importing pyplot alone, and this shall be imported as PLT. In order to make sure that the backend and the front end of our plots are in line, we will be giving percentage or modulus matplotlib space inline. So let's run this and then let's read in our image. I'm going to be reading in the image in the variable img using cv2.imread. The name of my image is going to be black and white image, and I shall make sure my flag is set to 0. Now that we have read in our image, our next step is to apply the Laplacian filter. Just a quick note and important information we have to keep in mind. This is that the Laplacian filter is a derivative of the Sobel gradient or the Sobel filter. It highlights the regions of rapid intensity change. So, to do this, let us create a variable called img_lap and assign the CV2, the Laplacian filter, to this. This filter takes in two arguments. The first being our source image and the second being the depth of our image. I'm going to be using the depth as cv2.cv_16u. So let's run this to make sure there is no error in our code. Now let us go ahead and create the code for displaying our image. We will be using the PLT code or the PLT library for displaying of the images. So plt.subplot, and inside this I'm going to get the values 1, 2, 1. Here, as you all know, 1, 2 is for the number of rows and columns respectively, and the last one represents the position. This is then followed by plt.imshow, and this will have our original image, comma, the CMap will be set to gray. This is then followed by plt.title, and over here I'll give original image. So after the title, I'm going to create the code so that x-axis and y-axis values are not going to be displayed in my image. So I'm going to say plt.xticks, within brackets open and close my square brackets. Similarly, plt.yticks, with inside the brackets open and close square brackets. Now let us do the same thing for displaying our Laplacian image. The only difference will be that when I do plt.subplot, I will be giving 1, 2, 2 to indicate that it's going to be in the second position. So then I'll have plt.imshow. Over here I'll have img_lap. CMap again will be set to gray. Then plt.title. Let's give the title of this image as Laplacian image. So okay. Then as usual, plt.xticks, open and close square brackets, followed by plt.yticks, open and close square brackets. Last but not the least, I have to give plt.show to display the image to us. So as you guys can see, I have the original image followed by the Laplacian image. So at this point, maybe in my screen, you guys may not be able to see the Laplacian image very clearly. So in your screen, if it is not clear also, please go ahead, zoom into the image to see the output. So now that you've learned about the Laplacian filter, there is another filter called the scar filter. The function used over here is cv2.scar, that is capital S C H A R R. This takes in four arguments. The first being the input image, the second being the depth, which can be either cv2.cv underscore 16u or cv2.cv underscore 64. Then you have the dx and dy, which is the x-axis or the y-axis in which the scar filter has to be applied. So why don't you guys go ahead, try the scar filter for the image. Thank you. See you guys in the next lecture.